नहीं लिखे थे सर।
हाँ सर, मैंने भी ऐसे मतलब नेम एंड रोल नंबर ठीक ठाक कर दिया मैंने, मतलब होम पेज बनाना था वो बना दिया। उसके बाद प्लेन पेज का नहीं हुआ सर।
हाँ, नेम एंड रोल नंबर तो मतलब वो पीडीएफ एडिट करके क्रॉप करके डाल
हाँ
सकते हो,
हाँ सर।
उसमें कुछ प्रॉब्लम नहीं है, बट रूल रूल को तुम प्लेन नहीं बना सकते ना।
ये सर, वही है सर। सर नेक्स्ट टाइम से नहीं होगा
सर
मिस्टेक।
हाँ सर, इस बार कर लीजिए सर, नेक्स्ट टाइम से नहीं होगा।
ठीक है, आई ऑलरेडी टोल्ड, दिस टाइम आई एम कंसीडरिंग बट नॉट फ्रॉम
ओके
द
सर,
नेक्स्ट टाइम।
थैंक यू सर।
थैंक यू सर।
सर रोल नंबर नेम ये सब जो फ्रंट पेज है वो WPS से बना सकते हैं क्या?
हाँ, दैट यू कैन डू।
ओके सर, थैंक यू।
So in the last class, I have introduced T-shifting theorem. Do you remember T-shifting theorem or T-shifting property?
यस सर।
T-shifting theorem, T-shifting property, or it is called also second shifting theorem. Fine. So directly I am coming to the formula. Uh, it is Laplace transform of what? F t minus a u t minus a. It is e to the power minus as fs. Okay, where that fs is what? Fs is Laplace transform of ft, and accordingly you can write the Laplace inverse formula. So Laplace inverse of e to the power minus as into fs is equal to ft minus a ut minus a. Now let us solve some problem based on this T-shifting theorem. Okay, before that I should mention this modification of T-shifting theorem. So that modification reduce some calculation. Okay, what kind of calculation it reduce? I will tell you. Before that, you should note it. Modification of T shifting theorem. It states that Laplace transform of it is ft minus a ut minus a. Na? In T shifting theorem, it is ft minus a ut minus a. Sometimes it can be taken ft ut minus a, ft into ut minus a. Okay, not ft minus a, ut minus a. If it is simply ft ut minus a, in most cases actually you will get this type of function, a function multiplied by a Heaviside function. Okay, so Laplace transform of ft ut minus a. How to find it? What is the formula? Actually, from that basic formula, you can derive the modification formula. It is e to the power minus as Laplace transform of f. Previously, it was Laplace fs था ना? It was fs. That means Laplace transform of ft था. ये Laplace transform of ft, right? But the modification rule says that if we take Laplace transform of ft into ut minus a, it is e to the power minus as into ft plus a. ft plus a. Fine. Now I will tell what is the advantage of this modification. For example, if I ask find Laplace transform of say t square u t minus 1. Okay, we need to find Laplace transform of t square u t minus 1. So the original form is that ft minus a ut minus a. It is the original form. But the problem is not given in the original form, right? Ut minus a, that means the form is t minus a form. So that t is not given in t minus a form, means t minus 1 form में दिया नहीं है ना ये. So we cannot say that it is of the form ft minus a ut minus a, right? It is not of the form ft minus a ut minus a. Do you agree?
So can you repeat again?
Look, to apply this main formula, t-shifting theorem formula, the function should be ft minus a ut minus a. So ut minus a is given, means t minus 1. Then ये जो ft है ये भी एक t minus 1 का function होना चाहिए ना, then only we can apply the t-shifting theorem, right? But it is not a function of t minus 1. So to apply t-shifting property, you have to express that function t square in terms of t minus 1, right?
Yes, sir.
Do you get it, everyone?
Yes, sir.
I am telling by using t-shifting theorem, the main formula. Okay, by the main formula, first of all, I am showing. So main formula say initially it is not possible. For that you have to express t square in terms of t minus 1. तो t minus 1 के टर्म में कैसे लिखेंगे t स्क्वायर को? t square, can I write this t minus 1 plus 1?
Yes, sir.
Now t minus 1 you assume it as a single term and then split it in the formula of a plus b whole square. So what it will be? This. So if we want to write t square in terms of t minus 1, so it is this t minus 1 whole square plus 2 into t minus 1 plus 1, right?
Yes, sir.
Now you substitute that t square. So Laplace transform of t minus 1 whole square plus 2 t minus 1 plus 1 into u t minus 1. Okay, so it is now ft minus a ut minus a form. Ft minus a ut minus a form, right?
Yes, sir.
Now you apply t shifting theorem. So it will be e to the power minus as. Now what is the value of small a? Actually ut minus a or ft minus a से a मिल जाएगा, तो a is what? 1.
Yes, sir.
A is 1. Okay, so it is e to the power minus 1 into s, that means s. Now Laplace transform of ft चाहिए, Laplace transform of ft. ये fs लिखना है ना, तो fs मतलब Laplace transform of ft. तो how to get that ft? We have ft minus a. So from ft minus a, we can write ft. So here I am writing, देखो, ft minus 1, it is our t minus 1 whole square to t minus 1 plus 1. Then what is ft? What is ft? This,
Yes, sir.
देखो ये टी स्क्वायर को एफ टी मत समझना, ठीक है, क्योंकि बोलोगे कि टी स्क्वायर, ये मतलब टी स्क्वायर को ही तो मैनिपुलेट करके ये टी माइनस 1 के होल स्क्वायर के फॉर्म पे आया, तो एफ टी इज अवर टी स्क्वायर. नो, it is ft minus 1. So from ft minus 1 you have to write ft. You substitute t minus 1 is equal to t, you will get ft. So ft is t square plus 2t plus 1. Now you write its Laplace transform, मतलब e to the power minus as into fs, and that fs is Laplace transform of ft. Now you tell me what is the Laplace transform of ft. There are three terms. तो फर्स्ट टर्म का लैप्लास ट्रांसफॉर्म क्या होगा? टी स्क्वायर का. Tell me what is the Laplace transform of t square?
Two by s to the power 3.
2 by
S to the power 3.
s cube. Yes. Actually it is factorial. So factorial 2 means 2. And what about 2t? Laplace transform of 2t.
1 by s square.
1 by a square. So it is 2 by a square. And 1?
So 1 by s.
1 by s.
1 by s. Okay. So that is our Laplace transform of t square ut minus 1. देखो तो बहुत सारा चीज यहाँ पे करना पड़ रहा है. ft into ut minus a, if that is the form, and if we want to apply this main form.
Sir.
हाँ.
Sir, that f of s is Laplace transform of f of t.
हाँ, Laplace transform of f of t. ऐसा यूजुअल नोटेशन ना. तो हियर देखो, यहाँ पे इसको अगर मेन फॉर्मूला से करने जाएंगे तो बहुत सारा दिक्कत है. फर्स्ट ऑफ ऑल, that function you have to express it in terms of t minus a. Then from that f of t minus a you have to find ft. Okay, so there are so many type of manipulation, but if you use the modification rule, modification of T shifting, it is very easier. You see,
Yes sir, direct हो जाएगा.
direct you will get. So I am showing how that same example alternative way. The Laplace transform of P square F, sorry, P square U P minus 1, U P minus 1. Now it is means according to the modification rule, it is our FT, correct? तो ये क्या होगा? E to the power minus AS. Now what is small a? UT
So
minus A से मिल जाएगा ना?
So
From
1.
UT minus A you will get A is 1. So e to the power minus AS. That means e to the power minus S. And the Laplace transform of what?
T
F of
plus
t
A.
plus A. F of t plus A. That means f of t plus 1. So we have to
Yes sir.
find ft is equal to t square. यहाँ से f of t plus 1 चाहिए. It is t plus 1 whole square. That means t square plus 2t plus 1. So Laplace transform of f of t plus 1, that means t square plus 2t plus 1. So e to the power minus s into same we are getting a 2 by s cube plus 2 by a square plus 1 by s. Is not it a simple form?
Yes sir.
Simple way, right? So if the function initial form it is not given in the form ft minus a ut minus a, rather it is given in the form ft into ut minus a, you apply the modification of t shifting. And if originally it is given in the form ft minus a ut minus a, then you can apply the main formula. Okay. एनी डाउट? बोलो दोनों मेथड में डिफरेंस क्या है ये समझो कि नहीं? It is by modification,
Yes sir.
T shifting. Modification, that is the main. Now let us see some exercise problem. See, we have to apply second shifting theorem on this function. So here the functions are defined on some finite interval or some infinite interval which is a subset of the positive interval, means 0 to infinity का subset है. So in that case, if a function is defined in an interval, then how to get the Laplace transform of it? So I told now that is kind of that piecewise function. So I am showing a first problem that t02. Okay, better to show problem number 4, cos 4t in the interval 0 to pi. 0 to pi. Now, what is the function then? If you want to write it as a single function in the positive real axis, then what it will be? How to express it? It will be related to what? Heaviside function. I told now how to represent a function in an interval as a heaviside function.
Yes, sir.
Cos 4t multiplied ut
UT.
minus 0 minus ut minus pi. Okay, that is the way. Any doubt? तो these are single piece, मतलब यहाँ पे एक ही पीस है तो प्लस प्लस करके और नहीं करना पड़ेगा. अगर यहाँ पे t कॉमा देके t ग्रेटर देन पाई लिखता, ऐसे लिखते, तो इस यहाँ पे प्लस t इंटू क्या लिखते, ut माइनस पाई, ऐसे लिखते. बट इट इज अ सिंगल पीस, so for that single piece only this term appears. Cos 4t multiplied ut minus 0 minus ut minus pi. Now you take Laplace transform. Laplace transform of this means cos 4t. Look, ut को 1 लिख सकते हैं, 1 minus ut minus pi. So you separate it in two parts, cos 4t and minus Laplace transform of cos 4t into ut minus pi, right? So Laplace transform of the first part that comes from the chapter 5.1, the tabular formula, right? Tabulated formula. What is it? S divided by a square
Minus a square.
16. A square plus a square.
So minus.
Minus in case of hyperbolic.
Okay.
If it is cos hyperbolic 40, then it is minus. Check it. You have the PDF, you can check it. Okay.
Yes, sir. Yes, sir.
And the second part, it is of the form ft into ut minus a, right? Because it is not in the form of t minus pi. अगर ये t minus pi की फॉर्म पे होता, then it is of the form ft minus a ut minus a, but it is not. So it is Laplace transform of ft ut minus a. Okay, तो क्या होगा? e to the power minus as. What is a?
So pi.
Are you getting all?
Yes.
Others? Here a, what is a? A is pi, right? Small a. ut minus a. Always compare with that. A is pi. So e to the power minus pi s. The form is e to the power minus as. No? So e to the power minus pi s. Next, it is by the modification of t shifting. So Laplace transform of f of t plus a. So ft cos 4t. Then f of t plus a means f of t plus pi. What is that? This. Our ft, it is cos 4t. So we have to find f of t plus a. By the modification rule, it is Laplace transform of f of t plus a, right?
Yes, sir.
तो cos of it is what 40 plus 4 pi. तो 40 plus 4 pi क्या होगा? ये cos 40 होगा ना? वो मल्टीपल सब मल्टीपल वाला फॉर्मूला से
Yes, sir.
एनी डाउट? ये cos 40 होगा, cos of 4 into t plus pi, it is cos 40 और minus cos 40. Tell me. No one is replying. ऐसे होने से कैसे चलेगा? मतलब बस मैं देख रहा हूँ कि वही अंकित ही रिप्लाई करे और कुछ और कोई कुछ नहीं बोल रहे हैं. तुम लोगों को थोड़ा दिमाग चलाना है कि नहीं?
सर माइनस होगा ना?
देख रहा हूँ. तो फर्स्ट ऑफ ऑल इट इज इवन मल्टीपल ऑफ पाई बाई 2, तो cos ही रहेगा. Now 8 into pi by 2 plus theta means it is which quadrant? Uh, 2 पाई मतलब कोई फर्स्ट क्वाड्रेंट पे पहुंच रहे हैं. वन टू थ्री फोर फाइव सिक्स सेवन एट फर्स्ट क्वाड्रेंट पे ही आ रहा है ना ये. 8 इंटू पाई बाई 2 प्लस
Yes, sir.
40 ये फर्स्ट क्वाड्रेंट पे आ रहा है. तो फर्स्ट क्वाड्रेंट पे ऑल पॉजिटिव, तो ये cos 40 होगा. फाइन. देखो इट इज योर टास्क. ये मैं मतलब कुछ भूल भी कर सकता हूँ यहाँ पे, क्योंकि मुझे सब कुछ मतलब याद नहीं है ट्रिग्नोमेट्री का. फिर भी मैं बता रहा हूँ, बट थोड़ा वेरीफाई कर लेना कि ये सही है.
सर cos थीटा प्लस पाई तो माइनस cos थीटा होता है.
हाँ,
सर cos थीटा प्लस पाई माइनस cos थीटा होता है ना?
cos थीटा प्लस पाई,
यस सर.
cos पाई प्लस थीटा 2 इंटू पाई बाई 2 प्लस थीटा, तो हाँ वो माइनस होगा. तो इसके साथ प्रीवियस का क्या रिलेशन है? ये थर्ड क्वाड्रेंट पे आ रहा है ना, तो इसीलिए थर्ड क्वाड्रेंट पे cos नेगेटिव, तो इसीलिए ये
यस
नेगेटिव
सर.
होता है.
ओके.
बट ये 8 इंटू पाई बाई 2 प्लस थीटा वो एक्चुअली फर्स्ट क्वाड्रेंट पे आ जा रहा है, एंड फर्स्ट क्वाड्रेंट पे ऑल पॉजिटिव. द फॉर्म इज मींस cos ऑफ n इंटू पाई बाई 2 प्लस थीटा ना, ऐसे वेरीफाई करते हैं ना. n इंटू पाई बाई प्लस थीटा, n इवन होगा तो cos ही रहेगा, n ऑड होगा तो cos साइन हो जाएगा. देन मतलब ये कौन सा क्वाड्रेंट पे पड़ रहा है उसके हिसाब से साइन डिटरमाइन करते हैं. यही ना?
यस यस.
So it is actually cos 40 होगा. So I am writing one more line, a by a square plus 16 minus e to the power minus pi s, and ये Laplace transform of cos 40. That means same, a by a square plus 16. Okay, so you can take s by a square plus 16 common, this, fine. Okay, I have to remove this. Any doubt?
No, sir.
No, sir.
No, sir.
Okay. Next, can you tell me, देखो अभी just if you know the function, if you know the function in terms of Heaviside function, then you can do the rest. Okay, like for the first, it is defined in 0 to 2. So in terms of Heaviside function, what it will be? Tell me. Same approach. ये जैसे किया है वैसे ही. क्या होगा बोलो?
T ut minus ut minus 2.
T ut minus ut minus 2.
T minus 2.
Yes. Or you can write in place of ut, you can write what?
1.
1. Here also you will get two parts, t and t into ut minus 2. Then you take Laplace transform, okay, and apply that modification of t shifting. कर पाओगे? For this t minus 2, can you tell me for 3? It is only right to the point 2, not a finite interval. So whenever this kind of condition is there, t greater than something, it is what? That function into ut minus that point. So it will be t minus 2, and according to the interval, it should be multiplied with ut minus 2 only. Right? So it is the ft. Any doubt?
No, sir.
You write
No,
down.
sir.
Okay, ये लिख के रख लेना, बाद में इसका just Laplace transform लेना. Now you tell me, to find Laplace transform of this function, which formula I will use? Better to use the main t shifting formula, not the modification, because the function is in the form of t minus a, na? ft minus a, ut minus a, right? Okay, I am showing. So it is problem number 3. ft, the function is our, I'm not writing in the form of ft. So the function is this. Okay, now Laplace transform of t minus 2 ut minus 2. So it is of the form ft minus a ut minus a. So you apply that modification, sorry, that main formula of t shifting. So it is e to the power minus as. A means 2, na? Laplace fs. Fs means Laplace transform of ft. So what is ft here? According to the main formula, what is ft here? It is f of t minus 2, right? It is f of t minus 2. So what is ft? ft, tell me.
30.
T. So we have to multiply e to the power minus 2s by Laplace transform of ft na. So it is what?
1 by a square.
Sorry, 1 by a square. And अगर तुम लोग चाहते हो, then you can apply the modification rule also, no doubt. In that case वो क्या करना पड़ेगा? That is by t shifting. So to apply modification, you have to separate it into two parts.
So this is normal formula.
That is by the main formula.
Okay, okay.
Ft minus a ut minus a. Alternative is that t minus 2 ut minus 2 na? So you write it in that way, t into ut minus 2 minus 2 into ut minus 2. Then Laplace transform of this will be what? Laplace transform of t ut minus 2 minus 2 constant है तो बाहर आ जाएगा 2 into Laplace transform of u.
तो फिर ये तो लेंथी हो जाएगा उससे.
हाँ ये लेंथी हो जाएगा फालतू में. तो अगर वही बोल रहा हूँ, if the form is given in as the form is given as ft minus a ut minus a, then you apply the main formula. And if the form is given in the form ft into ut minus a, then you apply modification. But तुम कोई भी प्रॉब्लम को कोई भी फॉर्मूला से बना सकते हो. मतलब given any form you can apply main formula as well as modification formula. But कौन सा बेटर है वो मैंने बताया तुम लोगों को. तो इसमें देखो फर्स्ट पार्ट के लिए मॉडिफिकेशन, राइट? फॉर द फर्स्ट पार्ट ft into ut minus a modification, so it will be e to the power minus 2s Laplace transform of f of t plus a. तो ft t है, f of t plus 2 क्या होगा? t plus 2. And ये तो that is a Laplace transform of Heaviside function का फॉर्मूला. Laplace transform of ut minus a क्या होता है? e to the power minus as by s, right? At the very beginning of this chapter I told Laplace transform of ut minus a, this e to the power minus as by s. So 2 into e to the power minus 2s by s. तो फर्स्ट पार्ट को सिंप्लीफाई करो, e to the power minus 2s Laplace transform of t plus 2 क्या होगा? दोनों पार्ट में Laplace transform of t हो जाएगा 1 by a square प्लस Laplace transform of 2 हो जाएगा 2 by s माइनस 2 into minus 2s by s. तो एक टर्म कट जाएगा ना, तो अल्टीमेटली रहेगा क्या? स्क्वायर. Okay.
Yes, sir.
So do you get it when to apply modification t shifting and when to apply the main t shifting?
Yes, sir.
Yes, sir.
So after doing 2 or 3 more problems, we will get it properly.
हाँ बोलो.
So after doing more 2 to 3 problems, we will get it properly, sir.
After doing
सर 2-3 प्रॉब्लम करने के बाद वो सर पता चल जाएगा मतलब.
no not 2-3 problem means first of all it should be clear when to apply the main formula and when to apply the modification. I told
Yes, sir.
if the initial form is ft minus a ut minus a, if this is the form, then you apply what?
The normal one.
Main. And
Yes,
if
the main formula, sir.
yes, and if the function is given in that way, ft into ut minus,
Then we will use the modified one.
Modified.
Yes, sir. Get it.
then you apply the modified one. तो इसीलिए ये जो प्रॉब्लम है, प्रॉब्लम नंबर 3, देखो इसमें t माइनस ए यू टी माइनस ए, सो इट इज ऑफ
Yes,
द
sir.
फॉर्म एफ टी माइनस ए यू टी माइनस ए, so better to use main formula. But you can do use the modification also, but it is lengthier in that case. Okay.
Yes, sir. Got it.
So similarly, problem number 5, 6, 7, these are defined over some finite interval. So you can represent this function in terms of Heaviside function. Then you take its Laplace transform. But by mistake, if you apply, like it is asked Laplace transform of t in the interval 0 to 2, and you are directly writing Laplace transform for t. It is what? It is 1 by s, sorry 1 by s square, which is not correct. अगर ये सब पता नहीं होगा तो तुम t का ही जो लैपलेस ट्रांसफॉर्म है वही लिख दोगे ना, 1 by s square, तो वो सही नहीं है. ये that interval is important. Okay?
Okay, sir.
ये गलती करता है, इसीलिए मैंने बता दिया. अगर if some interval is mentioned, then do not apply that tabulated formula. Okay. Now let us learn to find some Laplace inverse by using t shifting. Okay, Laplace inverse by t shifting. So I am showing the first one, 12, problem number 12. 12 to 17, there are some Laplace inverse problems. Okay. E to the power minus 3s, s minus 1 whole cube. So in case of inverse, what is the formula? T shifting ka inverse formula. This one. Laplace inverse of e to the power minus as into fs is equal to Laplace transform of ft minus a ut minus. Okay. So inverse case में ये main formula ही mainly use होता है, modification उतना use नहीं होता है. Problem number 12. Laplace inverse of e to the power minus 3s divided by s minus 1 whole cube. Okay. So first of all, you have to think whether can we solve it by any other formula except t shifting. Is it possible? Not possible, because the given function includes e to the power minus as type. अगर ये वाला रह जाएगा तो कभी भी और कुछ दूसरा नहीं आएगा. That should be मतलब related to Heaviside, means t shifting. Okay. If you find anywhere e to the power minus as related term, its Laplace inverse should contain Heaviside function. That means we have to use t shifting. याद रहेगा?
Yes, sir.
Now it is of the form e to the power minus as into fs. To apply t shifting, you have to think it as e to the power minus as into fs, na? So what is a and what is fs? You tell me. What is small a?
3.
Sir, 3.
3. And fs?
Sir, SQ.
1 by s minus 1 whole cube.
Okay. Sir, S minus 1.
Yes. The form is, देखो पहले फॉर्मूला लिख लेना साइड में, राफ में. Laplace inverse of e to the power minus as into fs. यहाँ पे वो f of s minus a जैसे नहीं मत सोचना, क्योंकि here we are not applying the first shifting. First shifting में ये अलग है, ठीक है. I am applying second shifting, तो it is fs. It is f t minus a u t minus, right? So now you compare. So what is a, what is small a, and what is fs? Is it clear? A is 3 and fs is 1 by s minus 1 whole cube.
Yes, sir.
फॉर्मूला के साथ मैच करके ये टर्म्स में लिख रहा हूं. इन फास्ट शिफ्टिंग अगर ऐसे होता, मतलब e to the power minus 3s नहीं रहता, तो इट इज f of s minus 1, राइट. मतलब फास्ट शिफ्टिंग अगर यूज करते एंड ये वाला नहीं होता, in that case it is, we have to assume it as f of s minus 1. That is a different thing. Now ut minus a, that we can write ut minus 3 हो जाएगा. Now what is f of t minus 3? f of t minus 3 we have to find, na? Then only we can write the answer. It is ft minus a ut minus a. तो ut minus a, ये तो ut minus 3 हो जाएगा. But what is f of t minus 3? For that first you need ft. Then you can find ft minus 3. So what is ft? Laplace inverse of fs. Right? And
Yes, sir.
what is the Laplace inverse of this? अब ये 1 by s minus 1 whole cube के लिए you have to apply fast shifting. अब ये एक फंक्शन ऑफ s minus 1 है, तो क्या होगा बोलो? For this function, now separately you consider this function and then you think how to find its Laplace inverse. The only way is that applying s shifting. तो s shifting में इसको f of s minus 1 सोचते हैं, right? तो what is a here? According to first shifting, what is a?
1.
फास्ट शिफ्टिंग भी यहाँ पे लिख लो फॉर्मूला, बोलो. Laplace transform of, sorry, in Laplace inverse form होगा, Laplace inverse of f of s minus a is equal to e to the power at ft, right? ये फास्ट शिफ्टिंग था. Now by the fast shifting we are going to find Laplace inverse of 1 by s minus 1 whole cube. देखो ये डायरेक्टली कर सकते हो. So here s minus 1 से a क्या है पता चल गया, a is 1, तो ये हो जाएगा e to the power t, and f of s minus 1 is 1 by s minus 1 whole cube. Then what is fs? 1 by s cube. अभी जो मैं fs बोल रहा हूँ वो वाला fs और ये वाला fs डिफरेंट है, वो मैं फॉर्मूला के साथ कंपेयर करके बता रहा हूँ. ओके, तो fs होगा 1 by s क्यूब, तो उसका इनवर्स क्या होगा? 1 by s क्यूब का इनवर्स
T square by 2.
t square by 2. So that is the function ft. Okay, so here देखो both of the shifting properties are being used. From fs to find ft we are using s shifting, and then overall we are applying second shifting. Now we have ft, then according to the second shifting ये e to the power माइनस एस एफ एस का लैप्लास इनवर्स होता है एफ ऑफ टी माइनस ए यू टी माइनस ए. नाउ स्मॉल ए इज 3, तो क्या होगा? f of t minus 3 ut minus 3. So f of t minus 3 means what? From ft you write f of t minus 3. This, it is f of t minus 3 multiplied by ut minus 3. That is by t shifting. And ये जो निकाला था ये by s shifting. बोलो क्या डाउट है बोलो.
No, sir.
अगर ये समझ गए हो तो मतलब यू कैन सॉल्व ऑल टाइप ऑफ प्रॉब्लम्स.
सर लास्ट वाला लाइन समझ में नहीं आया.
लास्ट वाला
यस सर.
तो e to the power minus a Laplace inverse of e to the power minus as into fs, that is the form by t shifting, right? So a already I have mentioned a is 3, a 3 है and ft क्या मिला है e to the 1 by 2 t square e to the power t. So according to the Laplace inverse, according to the t shifting theorem, Laplace inverse of e to the power minus as into fs ये होगा f of t minus a ut minus a, मतलब यही होगा लास्टली आंसर. ठीक है, f t minus a ut minus a. Now here a is what? According to the problem a is 3.
3. Yes.
तो f of t minus 3 ut minus 3, it is the answer. f t minus 3 ut minus 3. Now f t minus 3 क्या है वही लिखा है यहाँ पे. f t is e to the power t into t square by 2. Then what is f of t minus 3? t की जगह पे t minus 3 पुट कर
Yes,
दो.
sir, yes, sir.
ut minus 3 का तो और कुछ दूसरा एक्सप्रेशन नहीं है ना. ut minus 3 ut minus 3 रहेगा. But there are some specific function ft. So from that you can write ft minus 3. Fine. So here I am applying s shifting and t shifting simultaneously.
So, sir, attendance, sir.
सर डिस्कनेक्ट हो गया.
Attendance कैसे लगे? बहुत बच्चे निकल भी रहे हैं.
एसी है ना अभी.
अभी
अबे एसी वाले सर बुला रहे हैं.
चलो एसी चलो छोड़ो, मैथ सर को व्हाट्सएप पे लिख देंगे.
हाँ सर ऑल प्रेजेंट दे देंगे.
ऑल प्रेजेंट.